Today, we are watching the rapid compression of infinite human knowledge into a single, instantaneous, machine-generated answer. For 3 decades, algorithms acted as digital librarians. They indexed documents and returned ranked lists of links, a process known as deterministic retrieval. The burden of reading and synthesizing that information was left to the user. Generative artificial intelligence bypasses the index. It relies on probabilistic synthesis, a process where the engine reads the documents and mathematically constructs a direct answer on the fly. Analysts project a severe 25% drop in traditional search queries by 2026 as users migrate to AI assistants. That gap represents billions of user journeys that will never reach a website. The 10 blue links evaporate, replaced by a zero-click internet. Users no longer browse separate web pages to gather information. They hold continuous, highly specific conversations with AI assistants that do the heavy lifting of reading for them. Maintaining visibility in this environment requires a new engineering framework, Generative Engine Optimization, or GEO. GEO ignores human readers. It formats data specifically for the AI's internal architecture, a system known as the Retrieval Augmented Generation, or RAG pipeline. The RAG pipeline is the process AI models use to pull outside data, read it, and generate an informed response. Manipulating traditional keywords no longer works. Digital survival requires formatting your data so it successfully passes through the machine's extraction filters. The RAG pipeline begins at the vector database. When a user types a prompt like "best accounting software for SaaS," the system doesn't look for matching text. It translates that language into a vector embedding, a multidimensional coordinate mapping semantic meaning in a spatial grid. Traditional optimization relied on exact match text strings. If a user typed software, the system looked for the word software. Generative engines use query fan-out. The AI simultaneously executes dozens of subqueries, checking integrations, pricing, and reviews to gather comprehensive context instantly. A standard search query averages 4 words. An AI prompt averages 8 words, requiring a much wider semantic net. The database retrieves specific document chunks based entirely on their mathematical proximity to the prompt's vector, bypassing traditional domain authority rankings. A single target keyword is useless here. Marketers must build comprehensive entity maps, clusters of related concepts, and precise definitions that cover an entire topic. If your content lacks the exact mathematical coordinates to match a prompt, the system will not retrieve it. You are invisible before reading even begins. Retrieved data moves to the second phase, the context window. Document chunks attempt to pass into the model's active memory, but complex, JavaScript-heavy web design clogs this funnel with noise tokens, structural code consuming processing limits without providing meaning. Language models don't read full web pages. They have strict token limits. If a text chunk is obscured by complex code, the parser drops it entirely. Burying a factual answer inside long, winding marketing copy guarantees it gets ignored. If the machine cannot isolate the fact ceases to exist. The structural fix is the inverted pyramid. Writers must place a 40 to 60-word direct, unformatted answer immediately underneath an H2 header. Web developers must return to pure semantic HTML5. Clear heading hierarchies and table tags guarantee low-friction extraction by the parser. Sites are adopting machine-native protocols, deploying specific files like llms.txt and mcp.json. These act as cheat sheets, serving token-efficient data directly to AI agents. Visual web design matters strictly for humans. If the underlying code layer restricts the parser, the AI's context window will never process your data. Data that survives the funnel enters the final phase, the LLM synthesizer. Inside the context window, the AI applies a probabilistic trust filter. It evaluates the chunks to decide what gets cited and what gets discarded. The algorithm contains a heavy bias against self-promotional marketing copy and subjective, unverified claims. Inclusion requires information gain. Information gain is a metric used by search algorithms to measure the amount of unique, concrete data a document adds to a topic. Researchers at Princeton University tested how specific data injection affects this filter. Injecting concrete statistics and quantitative data into a text chunk increases its AI visibility by up to 40%. Utilizing direct expert quotations increases that visibility by another 30. The knowledge graph is an interconnected database of entities, people, places, and concepts, and the mathematical relationships between them. The traditional PageRank economy relied on hyperlinks. It has been replaced by the citation economy. The primary success metric is no longer localized website visits. It is share of model. Share of model is a measurement of how often an AI mentions your brand in response to a specific category of prompts. Generative models train heavily on consensus. They rely on specific categories of high-trust domains to establish absolute truth across the network. Legacy news organizations and established journalistic outlets are weighted heavily as primary truth anchors. Encyclopedic and academic databases serve as the foundational training corpus for almost all major language models. Community discussion platforms are utilized by the models to gauge real human consensus and authentic sentiment outside of corporate control. An unlinked brand mention on one of these high-authority nodes is mathematically equivalent and often superior to a traditional backlink. Digital teams must prioritize off-site public relations, third-party entity mapping, and independent corroboration. Optimizing your own domain's keywords is no longer the primary objective. Visibility in the intelligence age belongs exclusively to the organizations that format their reality as pristine, machine-readable data across the entire web. You must ensure you are the source code the AI chooses to compile.